Hello guys, this is we, and in this video we are going to talk about inheritance. Well, if you know a little bit of object oriented programming, that you might be aware that inheritance is one of the base principles or very important principles, or like methodology in OOP. Okay, so what is inheritance? Well, inheritance, in a general way, if you think, right, means inheriting. For example, if there is a very rich person, right, who's got like $100 million in the bank, and now he's got only one son. I'm talking about son in here, okay? So when that person dies, or it doesn't die, it's not necessary that that guy needs to die, okay? So the son is going to inherit all of the money and all of the assets and all of the business that the father is having. Okay, that's one example. Another example is what, for example, if and I'm not trying to be racist in here or anything like that, but if you see, right, a Chinese person or an Indian person or an American or European person, right, if they when they give birth to child, their childs have similarities in look or in color or in some way of hairstyle or some sort of look or some sort of genetic similarities, right? So that is again, it's called inheritance. Like they inherited some properties or some behaviors from the parents to the children's, right? So the same way inheritance works in OOP. You have a base class, or you can call them a parents, and you have a child class or subclass or derived class in the case of OOP, which have access to all the parent properties. Okay, if you don't understand, don't worry, we will be writing code just about now and see how it works. Okay, let's create a class. So before I create a class, I just want you to know that all the classes in Kotlin have one common superclass or one common parent. It's called any. Okay, so all the classes, and in Kotlin everything is an object of some particular class, right? So everything is a class in Kotlin. So they all have one common parent. It's called any. So they all are inherited from there. And now any does not have any properties. It's just an empty class. Okay, but it just had like couple of methods, toString and this and that. So yeah, not to worry about that. I just wanted you to know that there is a one common parent, a root parent, in Kotlin, for all the classes. And remember, this is not like Java's. If you are doing some Java, that Java has again one common class called object. This is not related to that. Objects is a lot of behaviors and stuff, but here in this case, any does not have any behavior or any property. It's an empty class, and you know that in Kotlin class can be empty without body, right? We just discussed last tutorial. Okay, so without further ado, let's get started. Okay, so let me create a base class. Okay, we will here go with the analogy of parent and child. Okay, so let's create a parent class. Okay, so one parent can have many child, as you know, right? But for now we will create a class parent. Okay, now parents got some looks, which I will give string, or I'm just gonna give array of string, but because why not, right? Array of string. Tall, I'll just write couple of those and some. Okay, now it's got the looks, and we'll just say where money is long, because this guy This guy is rich, so let's give them 100 million. Yeah, in Kotlin you can actually separate this number by this, so this looks good, right? Okay, this is 100 mil. And what else parent has? Some business means I don't know, I'll just write it in number, worth of sorry, this is 1 million. I'm just going to put 100 million, and this got business again of 100 million. Okay, so now you see parent is set. Now if you see, the parent class doesn't have any default constructor or anything like that, so you need to create at least one constructor. Okay, so the thing is, when you create a child, right, before that you need to have a parent. Okay. I think this analogy is not going to work. Okay, so let's get started with the analogy of a person and a student. Okay, so what I meant to say is, okay, the person can be student. Okay, so yeah, let's get started. Let's just create a superclass called person. Okay, now person's got name, okay, which is string, which will be empty, and person's got age, it's gonna be integer, default is 0. It's got what are the common things? Okay, because all the superclass, right, they just inherit common things, so we just need to write it down, a little bit of common things in here. So name, every kind of person have name, age, or some sort of ID. I'm just going to put int, but you can have like passport, or social security number, or Aadhaar card if you are from India. So those kind of things, so ID, I'm just going to put integer 0 again, because let's just say ID is 0, 1, 2 for now. Okay, so now this is like the common person. Okay, and now if you see, it doesn't have any constructor, so you cannot create any common person. You need to have a constructor. So I'm just going to give a primary constructor, and we are not putting any visibility, so I can just directly write it down: name, string, age int, and ID int. Okay, so when I'll be call it init, I will be just name, sorry, and just like name, age, ID. Oops, there you go. Okay, now person is created. Okay, and I'm just going to create one function to, like, print person or something. Print person, it's going to print it out. How? Print Helen. Name is this dot name slash and enter. Age is this dot age, and ID is this dot ID. Well, as you know, print person. Okay, so now we have a okay, and I'm just going to put person can be without ID for now. Okay, I just I know. No, I have some. So because I want to create another constructor, so just secondary constructor when a person can be in name, age, ID int. Okay, this will delegate to this with name, age, okay, and id we are going to give id. Oops, I need to do is equal to. Okay, so what now we have is we have a primary constructor. Just put it down just for the betterment of everybody else, right? Just so they can understand. So now I created a person class where I have a primary constructor, I have a couple of parameters, I have 3 properties, I have init, I have a secondary constructor, I have one function, okay, a member function. Now I'm going to create a base class. Okay, class. Now student can be person, right? So whenever you want to extend a class, okay, of superclass, you do colon person. Okay, now this is how you extend a class. Now here is a thing, okay, one of the really good thing about Kotlin is in Kotlin everything is a final. So if you are doing Java or something like that, right, it's very complicated static logic that you have, right? This static method, this static class, and all the static variables and stuff like that. Kotlin doesn't have anything like that. In Kotlin everything is a static or everything is a final by default. Okay, so in the case of class, all the classes are final by default, means they cannot be overrideable. They are not overrideable, you don't have permission to override it. Okay, so if you see, right, this type is final, so it cannot be inherited from, right? So you will be like, what, then how are we gonna do that? Okay, so if you want to override, you have to make that class open. Okay, first thing. So when you do open, right, it's showing, see, this subclass by student. So now open, now this class can be overrideable any number of classes. It's that easy. Now this class is, but now of course, now again one more error is this type has a constructor, because we need to construct it, right? It's got a primary constructor, and this guy doesn't have any constructor. Don't worry, so we'll create a constructor. We'll just take name, string will name, because student is also again, right, age and id we don't need actually, but let's create a person class with name and age. That's it. All the errors are gone. Now you can see in here, right, whenever, for example, you will create an object of student, right, internally there will be so student will inherit all of the properties and all of the member functions of person which are accessible. Okay, so now what we are doing is, when you create a student, internally the person class will also be initialized in here. Okay, so, and yes, now student already has these 3 properties, okay, name, age and id. So from their name and ages are here assigned already, and in init of this you can literally just say id, because it contains id, yeah, because it inherited it, right? If person has id, this guy's got the id. We don't need to like specially write it down of id. Boom. See, let's just call this main variable student1 is equal to student name bj. Okay, and sorry, age is gonna be 26. What are we waiting for? Oh, we have a third parameter, id is 22. Just write it down. Okay, see, okay, let's just see print. We don't need to undo print, and because you already have a print function, right? So you can just say print person, so this will print student. Why? Because it's already defined. So as you know, right, this is the main magic with the inheritance. You have a lot of stuff already defined. You don't need to do any of the work. Name vj 26 22, right? See, I didn't have anything in student, but still I'm able to do this. So this kind of inheritance is really, really important when you are doing some sort of database. For example, if you're writing an application, right, where you have like 4 kind of databases, and to create a common interface between all 4 kind of database, you can do something like open class db, which does read, which does write and everything, and with some specific parameters, and you can just override all those reads and writes methods, and just do the work. I think maybe if I'll create a project based video tutorial series on Kotlin, then I will be showing you guys. So don't worry about that. If you want that series, especially that yes, we want something that advanced level, where in real projects how to use inheritance and everything, just hit me up on my Twitter handle, or just message me on wherever you are watching these videos. So I will just get back to you as soon as possible. Thank you very much for that. Yeah, that's gonna be fun, I guess. So this is how you write, inherit from parent. Now you might be thinking that, okay, this is all good, but remember one thing, we have a secondary constructor, right? So if you have id available, you can actually write it down id, okay, and it will work. Yeah, and so what will happen is, in here, see, this is nothing, this is just an initialization or creation of this person class object. Okay, so whatever constructor you have, you can actually use it. Okay, now what if this guy doesn't have any constructor? How is gonna sound? Okay, now the student doesn't have any constructor, but person's got a constructor, so we need to initialize. How you gonna do that? It's simple, easy. You just have to, okay, in this kind of situation, you need to have a secondary constructor, right? At that time, you just take name as a string, age as a integer, and id as integer. It's the same thing, and then you use super keyword to initialize the person with name, age, id. It's that easy. Okay, in this case we don't need this. Okay, just one line and we have everything ready. Now student is all person and it should work. So as you can see, right? So second, whenever you have a secondary constructor, use super keyword to do all the kind of things. And okay, so this is just class level overrideable. What if you want to actually override this person and you just want to add type is equal to student? So again, I told you in Kotlin everything is explicit. We just need to write open. Okay, now it becomes overrideable. Otherwise it's not overrideable. You cannot override that. And we'll go to student. We'll just, and here when you override a method or member function, you have to write override function print person, right? Okay, so whenever you override the this print person, first thing you have to do, you have to actually call the this superclass function. Why? Because they might have some sort of initializations. I don't think it's required. Let's just see if it's throwing an error or not. We'll just do println with, I'll just add type student. Okay, and we'll do name this dot name because it's initialize. Let's just see, I think it should be this is gonna get interesting, I guess. Okay, let's see if it's compiles or not. Yes, it is compiling. So you don't need to actually call unless it's necessary, if okay, type student vj. Now you can see that, right? So we overrided this function, print function. Okay, so when you call it on student, what is going to happen is, instead of printing this, it's going to override this and it's to print this. Most of the time it's always good practice to do this kind of thing. Super.print person, why not just super.print person, but call this because this function might be doing some sort of work where it's initializing or it's calling some third-party service or something like that. So it's good idea, but in this example it's okay, it's not required, so it's just printing, right? So it's not required. Okay, so but you got the idea, right? If you want, so by default everything is a private, you cannot override it. But to make sure that function, to make it overrideable, you have to make it again open, and then you have to do override. But remember one thing, this is override when you do this overrideable, right? And some other class is actually inheriting from student, right? At that time this will become override open by default. So to stop that, you have to use final keyword. Okay, so now this guy is not overridable, and yeah, it's redundant model. Why? Because nobody's overriding. And now if I'll create some other third class, third class, right, with that class is inheriting from student, at that time I'll have to make it this final will work. So this function is print function is not overridable when you actually inherit from student. So yeah, so this is all good. Now you can even actually override the variables also. For example, this name string, this, right? What if this is just a readable? Okay, no, right now let's not go there, but yeah, you can actually override. For example, you can do something like where name string or something like that, but see, it's not overridable, right? Because it's already has. So what you have to do is we have to make it again this variable open, and then we have to do override. See, so this should work now again. Okay, so you got the idea, right? So whenever you have a base class or parent class, everything is private by default. To make anything open for overridable, okay, name won't be coming. Why? Because we actually recreated this name and we never assigned it, so in the constructor actually we can do something like this dot name is gonna be name. Let's see if it's work. Hey, yeah, it works. So what happens, okay, everything is a close by default if you see, right? But to make it everything open or overridable, just keep putting open, and whenever you do, just override or override, something like that. To stop override, just use final again to make it again kind of static, so nobody can override from this guy. Okay, so this is the whole concept of inheritance. Okay, I guess that's in that way we are done with the basic level of inheritance. Just remember these open and overridable things. Okay, so that was it, guys, for inheritance. Maybe I'll see you in the next tutorial with another advanced concept about OOP. So stay tuned. Thank you very much, guys.